Now I am going to take some shortcut formulas of differentiation for composite function. First one here, d by dx of sin ax. Sin ax. Actually, it is in the form of sin f of x. Look here, ax is there. Means it is in the form of not sin x. It is in the form of sin f of x. What is the f of x here? F of x is ax. Okay. Therefore, what is the differentiation of sin ax? Sin f of x. It is cos ax into d by dx of f of x. What is the f of x here? Ax. Where a is real. A is any real number constant except 0. A belongs to r minus 0. Okay. Now it is equals to sin differentiation is cos. Sin f of x differentiation is cos f of x into d by dx of this f of x. What is the f of x here? Ax. In front of sin, what is that? That is to be taken as f of x. Okay. That is cos ax into differentiation of x, a outside, into d by dx of x, because a is a constant. X differentiation is 1. So therefore it is cos ax into a into 1. A into 1 is a. X differentiation with respect to x is 1. Now a into 1 is a. You take a in the beginning. A cos ax. Therefore remember this one as a shortcut formula. D by dx of, therefore 1 by 1 I will list all the 6 differentiation as a shortcut. D by dx of sin ax is equals to a cos ax. Okay, for example, here only. For example, as a shortcut. So, for example, d by dx of, as a shortcut, you should remember all these formulas. Sin 3x. Sin 3x. What is the a here? A is 3. Okay, a is 3. That's equals to 3 cos 3x. That's all. Second one, d by dx of cos ax. That's equals to minus a sin ax. Sin f of x differentiation, cos f of x differentiation. As a shortcut, you try to write down the differentiation of sin ax, cos ax directly. So it is minus a sin ax. For example, d by dx of cos x by 2. What is the a here? D by dx of cos x by 2. A is 1 by 2. No? A is 1 by 2. So a is what? 1 by 2. So x by 2 means 1 by 2 into x. No? Therefore ax 1 by 2 into x. So a into x, a is half. Therefore the answer is half a minus half. Minus half minus a sin ax. Means sin ax is x by 2. Okay. Third one, d by dx of tan ax. That's equals to tan differentiation is sec square. Sec square ax into differentiation of ax. This tan f of x differentiation. Sec square f of x into d by dx of f of x is ax. Ax differentiation a into 1 a. Therefore it is a sec square ax. That's all. For example, d by dx of tan 2x. A is 2. That's equals to 2 sec square 2x. Sec square ax only. Here it is sec square ax only. So 2 is out, and sec square x should not be taken. Okay. A sec square ax only. Okay. D by dx of tan ax is a sec square. Here also ax remains. D by dx of cot ax. Cot differentiation minus cosec square. Therefore minus a cosec square ax. For example, d by dx of cot of x by 3. Here it is a is 1 by 3. Here a is what? 1 by 3. No. Therefore minus a. Minus a means minus 1 by 3 into cosec square ax. Ax is x by 3. Last one, fifth one, d by dx of sec ax. That's equals to, this is addition. Then sin 3x differentiation is d by dx of sin 3x is cos 3x into d by dx of 3x. Then d by dx of 3x, next step 3 outside d by dx of x. Then 3 into 1, 3. So waste of times. straight away you should write d by dx of 3 sin 3x is 3 cos 3x. So this is the shortcut formula helps in writing differentiation of trigonometric function with ax. Okay, sec ax, it is a sec ax into tan ax. For example, last one, d by dx of cot ax, not cot, cosec ax. And the cosec differentiation minus cosec into cot. The cosec ax differentiation minus a cosec ax into cot ax. These formulas are to be remembered as a shortcut. Even though these are seems to be a formula, suppose you are practicing a little bit. Sincerely you are practicing the problems of differentiation. So these formulas will be actually, it will be at your tip of the tongue. So differentiation formulas are very simple and easy formulas actually. So while solving the problem, a little bit concentration is given. Then while a little bit concentration is given to remember all these shortcut formulas, then definitely will be at your tip of your tongue. Okay. For example, d by dx of sec of 5x, a is 5, okay, a is equal to 5, is equal to a into means 5 into sec ax into tan x, ax means 5x, sec 5x into tan 5x, okay. And one more example, d by dx of cosec ax, cosec x by 2, cosec x by 2, a is 1 by 2. Then put the cosec ax differentiation, it is minus a is 1 by 2 minus a cosec ax into cot ax is cosec x by 2 into cot x by 2, okay. Ax differentiation, hence onwards I will write straight away the ax differentiation, okay, sin 3x differentiation, d by dx of sin 3x, 3 times of cos 3x, d by dx of cos 5x minus 5 sin 5x, d by dx of sec 3x, 3 into sec 3x, 3 is the a here, 3 into sec 3x into tan 3x, d by dx of cosec 5x, a is 5, minus 5 cosec 5x into cot 5x, okay, cosec x differentiation minus cosec x into cot x. If it is ax is there, only a outside, minus a cosec ax into cot ax. Okay. So let's take another 2 more problems from the textbook. Differentiate the following with respect to x. Differentiate the following with respect to x. Differentiate the following with respect to x. WRT means with respect to x. Okay. WRTx means with respect to x. First one, it is cos root x. And second one, 2 cot x square. 2 into square root of cot of x square. Third one, it is cos x cube into sin square. Cos x cube into sin square x raised to 5. Cos x cube, cos of x cube into sin square x raised to 5. Okay. Last one is little bit technical one. Let's see later on. First one, differentiate with respect to x means you have to take d by dx. First one is d by dx of cos root x. D by dx of cos root x. That's equals to cos f of x differentiation. It is in the form of cos f of x. F of x is root x here. Okay, the f of x root x. So I am writing something in bracket and round up. Things are written in bracket and I am rounding up the things. No need to write all those things in the examination. For your clarity, these things are written. Okay. Cos f of x differentiation, it is equals to minus sin f of x into d by dx of f of x. D by dx of cos f of x is equals to minus sin f of x into d by dx of f of x. That's equals to minus sin root x into what the differentiation of root x 1 by 2 root x. Okay, root x differentiation 1 by 2 root x. I am not writing because d by dx of root x is 1 by 2 root x. It is the what it is video. You can revise the video. If any clarity is not there for you, you can revise it, no? So that I am repeating the formula. D by dx of sin f of x is cos f of x is minus sin f of x into d by dx of f of x. So here it is not necessary to write the formula because you can have that what it is formula by listening it once again, by revising the video. Okay, it is sin root x minus sin root x upon 2 root x. Okay, into 1 by 2 root x means a into 1 by b is equals to a by b, a into 1 by b, a into 1 by a upon b upon b. So that's one. And second one is d by dx of d by dx of 2 into square root of cot x square. D by dx of 2 into root of cot x square. Now look here, 2 is outside, 2 is a constant, 2 is a constant, should be taken outside by differentiating. Constant into function is there, constant should be taken outside. 2 outside into d by dx of root of cot x square. Now look here, at the outset, it is which type of differentiation? At the outset, it seems to be root of cot x square, means it is root f of x. It seems to be what? Root f of x differentiation. Really it is root f of x differentiation. What is the differentiation of root f of x? Well, it is there, no? First of all, therefore it is root f of x differentiation. What is the root f of x differentiation? 1 upon 2 root f of x into d by dx of f of x. Okay. So I won't write the formula, I told you. So d by dx of root f of x is 1 upon 2 root f of x into d by dx of f of x. Therefore 2 into 1 upon 2 root, 2 is the constant taken outside the differentiation, d by dx taken outside the d by dx. Now I am differentiating this function. This function is in the form of root. Inside is f of x, root f of x. What is the root f of x differentiation? 1 upon 2 root cot x square into differentiation of f of x. What is the differentiation of f of x? Root f of x differentiation is 1 upon 2 root f of x into d by dx of inside f of x. F of x is cot x square into d by dx of cot x square. D by dx of root f of x 1 upon 2 root f of x into d by dx of this inside function means into d by dx of cot x square. 2 cancelling. Now I have to differentiate cot x square. Can you tell me what is the differentiation of cot x square? It is in the form cot f of x. Cot x is not there. Cot x square is there. X square is also a function of x other than x. Along with x, some additional terms are there that is to be taken as f of x. Therefore, it equals to 1 upon root cot x square into differentiation of cot. Now, first of all, at the outset it is cot here. Okay, at the outset it is cot. Therefore, cot differentiation minus what it is? Cot differentiation minus cosec square f of x. Cot f of x differentiation minus cosec square f of x into d by dx of x square. Simply x is not there. It is in the form of cot f of x. Cot f of x differentiation minus cosec square f of x into d by dx of f of x. What is the f of x here? X square into d by dx of x square. Try to understand the point here. It is not simply cot x. X is there. X square is there. Means there is f of x. Therefore, it is cot f of x differentiation. Cot f of x differentiation minus cosec square f of x into d by dx of this f of x. F of x is x square. Now x square differentiation is 2x. 1 into minus is minus. Write like this. Minus cos x square x square. That's equals to minus cos x square divided by root of cot x square into d by dx of x square. D by dx of again it is 1 by a into b. It is b by a. Okay, b by a. Minus into plus is minus. Then minus cos x square is taken here, and it is root of cot x square. Then into d by dx of x square. Now I have to work out d by dx of x square with the d by dx of x square 2x. Finally, write it here. Differentiation of x square is 2x. Finally, write like this. It is minus 2x. This 2 is taken first. Minus 2 this variable. Then cos x square all divided by the root of cot x square. It is a function of a function of function. First the root function is there, then cot function is there, and then x square polynomial function is there. Function of function of function. I will repeat once again. So d by dx of 2 root cot x square. 2 constant outside. Then d by dx of root of cot x square. Any constants are there, constant can be taken outside. Now look here. At the outside root is there. Therefore root differentiation. What is the root x differentiation? 1 upon root x. Root f of x is there. But simply x is there. Cot x square means f of x. So it is 1 upon 2 root f of x into d by dx of this inside. So now I will differentiate cot. So 2 cancels here. 1 upon cot x square as it is. 1 upon cot x square as it is. Now I will differentiate cot d by dx of cot x square means I will differentiate cot. What is the differentiation of cot? Minus cos x square. Simply cot x is there. I can write it as minus cos x square x. But x square is there. Means it is in the form of f of x. Therefore minus cos x square f of x into d by dx of this x square means f of x. Differentiation into d by dx of f of x. X square differentiation is 2x. So finally it is minus 2x into cos x square upon root of cot x square. Mind it now, always into d by dx of f of x should be taken in the numerator. D by dx of f of x should be taken in the numerator, not in the denominator. Now coming to the last one, third one, d by dx of cos x cube into sin square x raised to 5. Okay. Can you tell me? It is in the form of u into v. Two functions are in the product form. One is, yes, two functions are in the product form. Cos x cube one function and sin square x raised to 5 another function. Both are in the product form. Okay. Therefore, so first of all, apply the product formula of differentiation. It is u outside. First of all, take the product formula differentiation into d by dx of, it is sin x raised to 5 the whole square. Sin square theta is taken as sin theta the whole square. Okay, sin x raised to 5 the whole square. Sin square theta is nothing but sin theta the whole square. Therefore whole square is taken plus why whole square is taken? So because actually it is in the form of f of x raised to n. Okay, so it is in the form of sin square x raised to 5 means sin square theta, sin square x we did, sin square x differentiation is sin x the whole square. Therefore for any trigonometric function raised to n is there, that should be taken as whole raised to n. Then it belongs to the category of f of x raised to n. Plus v sin square x raised to 5 are not necessary because I am not differentiating this term. Therefore I am writing sin square x raised to 5 as it is. Here I have written sin square x raised to 5 as sin x raised to 5 the whole square. Sin x raised to 5 the whole square, because then the idea will be clear. It is in the form of f of x raised to n. F of x raised to n differentiation is n into f of x raised to n minus 1 into d by dx of f of x. Sin square x raised to 5 into d by dx of what it is? Tell me inside function. It is, sin square x raised to 5, sin square x raised to 5. It is v into d by dx of what? Cos x cube. Okay, so it is u into v for u means cos x cube outside into differentiation of sin square x raised to 5. Sin square x raised to 5 is written as sin x raised to 5 the whole square. We have the idea taken the form of f of x raised to n plus v outside sin square x raised to 5 into d by dx of u cos x cube. I have just applied the product formula of differentiation u into v, u outside differentiation of v plus v outside differentiation of u. Now I have to differentiate this sin x raised to 5 the whole square and this cos x cube differentiation. Okay, that's equals to cos x cube into. Now just listen to me. It is in the form of f of x raised to n. What is the f of x raised to n differentiation? N into n is 2 here. F of x. What is the f of x here? Sin x raised to 5 raised to n minus 1. 2 minus 1 into d by dx of f of x. What is the f of x? Sin x raised to 5. Okay. Plus sin square x raised to 5 into d by dx of what it is? Cos x cube differentiation. It is not whole raised to n, not that. Simply cos x cube. Therefore, it is cos f of x. Cos f of x differentiation is minus sin x cube into d by dx of x cube. It is not. It is in the form of cos f of x. Cos f of x differentiation minus sin f of x into d by dx of f of x. Cos f of x differentiation minus sin f of x into d by dx of f of x. This is in the form of, I have differentiated these two. Okay, this one is in the form of f of x raised to n. N into f of x raised to n minus 1 into d by dx of f of x. What is the f of x here? Sin x raised to 5. Okay, here what is the differentiation? Cos f of x differentiation minus sin f of x into d by dx of f of x. It is in the form of f of x raised to n differentiation. It is in the form of cos f of x. F of x raised to n differentiation n into f of x raised to n minus 1 into d by dx of f of x. Okay, it is equals to, now we will take 2 in the beginning, 2 times of cos x cube into sin x raised to 5, sin x raised to 5, raised to 2 minus 1 is 1, a raised to 1 is a, 2 raised to 2, right, 4 raised to 1. Now tell me, what is the differentiation of sin x raised to 5? In a single stage to write sin differentiation, now it is in the form of sin f of x, okay, sin x raised to 5, sin f of x. Simply sin x is not there, sin x raised to 5. X raised to 5 is to be taken as f of x. Sin x raised to 5 differentiation, it is sin f of x, cos f of x means x raised to 5, into d by dx of x raised to 5. Straight away I will write, into d by dx of x raised to 5, 5x raised to 4. Okay, understood? Sin, like this you have to skip the steps, some unnecessary steps you have to skip and write it directly. Sin f of x differentiation, cos f of x into d by dx of f of x. Here f of x is sin f of x, in front of sin, that is the f of x. X raised to 5 is f of x. Therefore, sin f of x differentiation, cos f of x is x raised to 5 into d by dx of x raised to 5, 5x raised to 4. That's all. Plus here it is sin square x raised to 5. Plus here the minus is there, minus into plus is minus, okay, plus into minus, minus sin square x raised to 5 into sin x cube into the differentiation of x cube, 3x raised to 3 minus 1, x raised to n differentiation, simple function differentiation, x cube differentiation, n into x raised to 3 minus 1, 3 into x raised to 3 minus 1 is 2, x raised to n differentiation is n into x raised to n minus 1, therefore it is 3 into x raised to 3 minus 1, 3 minus 1 is 2. Now, that's all. Differentiation is over. Write it neatly. Finally, first write the constant 5 into 2 here, 5 here to 10. Then variable x raised to 4. Then trigonometry and other functions. It is cos x cube, sin x raised to 5, cos x raised to 5. 1 minute. So let us use one trigonometry formula here. Here is 2, no? Just try to understand. Here is sin x raised to 5. Here is cos x raised to 5. So here is one formula, 2 times of sin theta cos theta is equals to sin 2 theta, no? Actually in differentiation, that is the main step. Differentiating the function is nothing. Once you understood the composite function differentiation, then so you won't get any varieties of differentiation. But once the differential coefficient you got, write it in the structured manner. That is the important point here. So it is, once you understood the composite function differentiation, and then you won't get any difficulty in differentiating the function. Okay, so but you have to understand the differentiation of composite function properly. So then differentiation process will be simple. Then simplifying the term is very important. Okay, so here it is. So 2 times of sin x raised to 5 cos x raised to 5. So in theta place what is that? X raised to 5. Theta place what is sin theta cos theta. Theta is x raised to 5. Therefore it is sin 2 theta. Sin 2 theta means sin 2x raised to 5. Understood? Sin 2 theta. Theta is x raised to 5. Sin 2 theta. Theta is x raised to 5. You know? So all these 3 underlying terms are clubbed to get one single term. Sin 2 times of sin theta, 2 times of sin theta, cos theta equals to sin 2 theta, sin 2 into x raised to 5. Now what are the terms remaining now? One cos x cube remains. Another one is 5x raised to 4 remains. Okay? Minus, here we write it as 3x square. Number first, then variables x square, then what? Sin square x raised to 5 into sin x cube. Okay. Now, 5 into, let us write it in the proper order, 5x raised to 4. Then sin 2x raised to 5 into cos x cube minus 3x square sin square x raised to 5 into sin x cube. Okay, the final answer. Now can you try the differentiation of some composite functions? Try the differentiation of some composite functions. First one, using the AX formula, differentiate all these things. AX formula, sin AX, cos AX. Okay, in a single step you should write the answer. First one is sin 10x. Sin 10x, sin AX differentiation, d by dx of sin AX, a cos AX, sin 10x differentiation, d by dx of sin 10x, 10 cos 10x, like that. Try to write like that. Second one, cos x by 4. Third one, tan 2x. Fourth one is sec 5x. Fifth one is cosec 3x. Sixth one is, it is sin cos tan sec cot x by 3. Okay, cot x by 3. All are AX category formulas. All are AX category. Okay. Next one, sixth one, sin 3x upon cos 4x. It is of the form u upon v. Okay, it is of the form u upon v. So quotient formula is to be taken. But while differentiating sin 3x, you can use the technique of AX. What is the sin 3x differentiation? 3 cos 3x. What is the cos 4x differentiation? AX is 4x, means A is 4. Therefore, cos AX differentiation minus sin AX minus 4 sin 4x. Like that, use the shortcuts. And seventh one, it is x square plus x plus 1 into, it is sin of 4x. It is in the which form? Tell me. It is in the form of u into v. But x square plus x plus 1, the whole square let us take. X square plus x plus 1 is in the form of f of x raised to n into f of x raised to n minus 1 into d by dx of inside, while differentiating x square plus x plus 1. Okay, first of all apply the u into v formula. It is u into v, x square plus x plus 1 into d by dx of sin 4x plus sin 4x into d by dx of x square plus x plus 1 the whole square. Okay, sixth one, square root of sin x plus cos x. Square root of sin x plus cos x. It is in the form of root f of x. And sixth one, 1 upon sec x plus tan x the whole square. It is in the form of 1 upon f of x raised to n. Try all these problems. Tomorrow I am going to teach one more type of differentiation, that is differentiation of implicit functions. Okay. Once you understood composite function differentiation, then differentiation process will become simple. Differentiation topic will be simple.